Hello friends, this question is from the test series number 1. Subject is network theory, topic is sinusoidal statistical analysis. It's a 1 marks problem. Question says that we have a expression of the current IT which is 3 plus 4 sine 100t plus 45 and 4 sine 300t plus 60 degree phase. So actually we have a current IT which has a DC component and AC component both. And we need to calculate the two values. Actually we need to calculate the ratio of two values. First is the RMS value, that is K1. Another is the power dissipated in the circuit, that is K2, and we need to find the ratio of both. Okay, so RMS value is like the RMS value of the sinusoidal signal is Vm by root 2. RMS value of the DC signal is V square. But what if you have a more than one signals in the circuit? Then the overall RMS value is the under root of RMS value of individual signals. This is a general formula in the RMS. If you have n signals and you want the overall RMS value of the signal, so what you need to do, calculate the RMS value of the individual signal, take the square, add them, and take the square root of the overall. Okay, this is the formula, standard formula. So here, because the signals are very standard, so we don't require to use the formula of calculating RMS. You know, the general formula of VRMS is what? Under root of 1 by t integral 0 to t V square V max square dt. It's a formula for calculating RMS signal, but we don't require this formula here because for sinusoidal signal we already know the RMS value, and for DC the RMS value is the square of the magnitude. So just simply use the values here. So for this 3 is like 9 plus V2 is like 4 by root 2 whole square, and this V3 is like 4 by root 2 again whole square. So the value is comes out as 5 ampere. So the VRMS, the RMS value of the voltage of this system is RMS value of the current. Sorry, we are calculating the RMS value of the current here, and I have taken the voltage expression everywhere. Anyhow, this formula, the idea is general. Okay, it's for voltage or current, RMS value of any signal, but for our case we have the current, so it's more suitable to take the symbol as IRMS. Okay, but the value formula is right, so I can write it down here as IRMS is equal to under root of I1 square plus I2 square plus I3 square, so on. Okay, so for that we have calculated the IRMS value. Second is calculate the power dissipated in the circuit. So power dissipated, which is the IRMS, is defined as K1. So this is the value of the K1. So K1 is 5. Value of K1 is 5 ampere, and the K2 is the power dissipation. You know that in the circuit the power dissipation only occurs in the across a resistor, and in the circuit we have a 10 ohm resistor. So the value of the power dissipation is I square R. Across the resistor we have the power formula I square R, so that is 5 RMS square into R, it is 10. So power total 250 watt power is dissipated, and in this circuit it is given that the power dissipated is equal to the K2. So K2 is the symbol for power dissipated. So the value of my K2 is what? The value of the K2 is 250 watt, right? So the value of the K2 is 250 watt. Value of the K1 is 5 ampere, but the question says that calculate the value of K1 by K2. We need to calculate the K1 by K2. Okay, so we know the K1, which is 5. We know the K2, which is 250. So K1 by K2 is 5 upon 250. Okay, which is 1 by 50, right? And but in the problem we need to calculate the K2 by K1, right? We need to calculate the K2 by K1. So if a K1 by K2 is 1 by 50, so K2 by K1 is 50. So 50 is the answer. Okay, so it's directly formula this problem based on the identities of the RMS. Okay, and the recent years we are getting this problem based on the RMS also. Like in the last year also we have this one signal. For that we need to calculate the RMS value. Okay, so every year, recently from last 2 years we have observing that we are getting very regular based problem of problem based on the RMS values for EC students also, for electrical student also, and even for instrumentation student also. Okay, so please consider this topic as a very important topic. You are required and solve the various types of problem based on the RMS value. Thank you.